So please make sure you have a new project open. Set it to week 11 underscore recursion. And we're going to get busy working on some examples of recursion. Does anyone know what recursion means, by the way? Tom?
Call a method within itself?
Yep, calling a method pretty much within itself. It's like you taking a camera and looking into a mirror. Has anyone ever done that before? Or you put up a mirror in front of a mirror and it goes on forever. First name again? Gabriel. Thank you, Gabe. Okay, so when we're talking about recursion, it's exactly like, that's nice, it signed me out. Okay, it's exactly like what we see right here with this, this screen. Stop. There we go. Recursion is pretty much just exactly what you see. The example I was talking about is like either taking a camera and peering into a mirror or taking two mirrors and facing each other. It basically reflects back and forth upon itself to infinity, right? With recursion, what you're doing is you have a class or a class method that when invoked inside the method definition, it actually calls itself to perform some type of action. Everything that you can do in a loop, you can pretty much do in recursion, except for some of your for loops. But other than that, everything that you could think about doing like in a while loop, you can do with recursion. So recursion, basically, it's when we have an algorithm that we know we're going to need to be repeated upon itself over and over and over again. Maybe it's a mathematical sequence we want to have ran. Maybe it is some type of search algorithm. It could be any of those, or whatever you can imagine, something that needs to be ran over and over again. For example, the games that you guys created could really have used recursion, where you constantly are just looping back upon itself, calling the main method, which invokes the user asking a question and answering and so forth. So a recursive algorithm then is taking a group of problems and it's breaking it into sub-problems, smaller problems, and it's applying that same algorithm repeatedly upon itself. Recursive method is just exactly that. It's a method that calls itself. All right, so let's take a look at an example here. This is in your textbook, actually. The method here is called countdown timer. This is a great example of recursion at work. You could write the same class with a loop, and the loop would solve the issue of it calling itself. But in this example, recursion allows you to do that without a loop. So at the top, you can see that we have the public class countdown timer. This is the name of the class. And inside the class, we have a public static void countdown method. And the countdown method takes a int called countInt. So it means that you could pass in any number you can imagine. Now, when you call this number, when you call the method, the first operation in the method says if the countInt is less than or equal to 0, system out print line, go. Else, system out print line, passing in the number itself, the countInt, whatever that number might be, and then the next method is countdown, the same method again, with a subtraction going on inside the method parameter, which is totally legal. And so in this instance, The actual algorithm that's being done is the mathematical algorithm, and it's done inside the method signature itself. You could put that that operation down even further. You could put it inside the countdown itself and have some other if-else logic. But as you can see here, this is where the method calls itself, and it basically says whatever the number was, go ahead and subtract it by -1 again. And when it hits that, when it hits this part of the method, you can imagine it looping back up, comes back in, and it says if the count int is less than or equal to 0, go, or count int, whatever it is now, because now the variable is less than what it was before, and subtract it again. And this would continue on until it's done. All right, let's go ahead and just type this piece of code out for example. Go ahead and open up IntelliJ. And we have our project created. So let's right-click on source. And we're going to create a class, and we're going to call this our, let's just call it counter. And we're going to create a public static void count. You could call it count int, you could call it count. It could be anything you could imagine here. I'm just going to call it count for simplicity. And it's going to take an int variable, and we'll just call this num. And so we're going to ask the question, if num is less than or equal to 0, we want to exit from the sequence and print the signature message. So you can imagine, here's the logic, right? 3, 2, 1, beep, right? Go. So we're going to print the go message. So system.println go. We're going to have on this an else, and we're going to say system.out.println the number, because we want, if it's not a go, then we want to at least print the message of what we're putting on the screen, right? So we're going to system.out.println the number, and then let's do count num -1. And that's it. That's it in a nutshell. It's the most simplest of recursion methods you can imagine. Let's go down to the bottom. We'll type PSVM, public static void main method. And we're going to call count. And I'm going to put in 10 is our counter. Okay? Very simple recursion example. So if we run this, go ahead and run it on your desktop, on your laptop, so you can see what happens. And here you can see it just immediately counts down. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay. Ezra, are you the only new person coming in?
I think.
Okay. Anyone seen Ivan or Irvin? Ivan or Irvin? Anybody? Okay. So this is an example then. Did everyone get their code to run? Very simple example of recursion. Now we could take this a little bit further, and we could add a timer to it to pause, right? And the way we would do that, let me get this. We basically just want to add a delay. My eye is itchy. We could come over here and we could use time unit. Okay, and if you look, time unit imports Java util concurrent time unit, and then this is a static type class call, so we're going to use the seconds, and then we're going to say sleep, and we're going to give how long we want to sleep. So we're just going to say 1. Okay, and this is going to throw an exception, so what we're going to do is add the exception to our method. And we'll add the exception over here to our method. Okay? Everyone see that? So now when we run this, this is actually going to give us a more genuine pause. So I'm just going to say 3 seconds for my run. We'll run the counter, and you can see that now it's counting down. Right? Very simple. Any questions so far? Basic recursion. Very, very easy to use. So again, to reiterate, when we talk about recursion, it's just a method calling itself to perform the action. Let's go ahead back to our slides for a moment. So we have the initial method call here. This is calling it. And this is where the recursive method is identified, the internal logic, and then inside the method, it's calling itself. Okay, let's talk about another type of recursion, where recursion is actually very powerful. And this actually gets into items that, types of algorithms that are very important to know. This is called a binary search. A binary search. Is anyone familiar with that term before? Anyone read this before? So a binary search is, in principle, it's where you have a collection of sorted values, and what you want to do is you want to find if the element is in this collection of values. So let's say that I had an array of 5,000 in length, and I want to find out if I have an item in that collection of 5,000 numbers. All right. First requirement is that the array must be sorted. If it's not sorted, then the binary search won't work. What the binary search does, in principle, is it takes the length of the array and it divides it by 2. Okay? So when I have an int and I divide an int by 2, what do I get? Well, I mean, let's say the int is, let's make it a more complex number. You guys have your calculators on your phones or laptops with you? Okay, here's the number, 47. Divide 47 by 2, what do you get? But when you're dividing ints, what do you get? There you go. You get just the number. You don't get the remainder. So in principle, the way this works is if I have a collection, say, of 5,167 items, I divide it by 2, I'm going to get the midpoint. And I have to ask the question at the midpoint. Is the number I'm searching for greater than or less than the midpoint number? So I've basically taken this wide collection, I've divided it by 2, and I said, okay, at the very center of this, the number I'm looking for, because I don't know if my number is going to be before the midpoint or after the midpoint. Because remember, these are a random set of numbers that have been sorted. So it could be 1, 5, 7, 9, 10, 11, 12, 15. It could be anything, right? As long as it's sorted. So I take the midpoint in my array, and now I'm asking the question, is the number I'm looking for less than or greater than the midpoint? If it's less than, then I take the midpoint and I lop off the rest of the array, and now I pass back in the array again, and I do the same sequence. Go to the middle of that new array, and I say, okay, what is the midpoint of this new array? Is it less than or greater than? Oh, it's less than. I lop it off again. I go to the midpoint of the next array. Oh, it's greater than. Lop it off again, and I keep doing that. Binary search. Idea is I'm only searching in groups of 1 or 2, right? How many of you understand so far what I'm getting at? All right, so let's look at the example. So we're trying to guess a number, and in this example, we're going to first get the high and the low value. Same principle, right? Let me ask you this. Why would I want to use a binary search versus going a step increment search? Yeah, a step increment search would technically take longer if the list is in number, whatever that in number is. If it's only like 10, it's going to be so fast it doesn't matter, right? But if the list is like into the hundreds or thousands, doing a binary search will find the number faster than doing a stepped search. Okay? So here in this instance, we're playing a game. We have Francisco. What is your, I want you to think of a secret number in your head. Okay? You got the secret number?
Got it.
Okay, so we're going to play the game. Looking at the code, we're going to ask, here's the values. We got low val and high val. Okay, so we take the low val and the high val. And we're going to say system out print line. Is the mid val, is this it? Low, high, or yes? Right? And so if my low val, let's say our low val is, it's a number between 10 and 50. All right, so now I want you to think about a number between 10 and 50. You got it?
Got it.
Okay, you don't have to make it difficult for us. It could just, for this purpose, it just needs to be, you're the number bearer, right? So a number between 10 and 50. I come in, I take the number between 10 and 50, I add it together and I divide it by 2. So what's 10 plus 50? Divided by 2 is 30. And so I ask the question, is it 30? Low, high, or yes?
Low.
All right, so it's low. So the answer the answer we're expecting here is L. So if the answer is L, so now we're going to take the low val. Let's go back up here again. Where's my low val? So use case, if it's not L and the username is not, and the username is H, we're going to say thank you. Else, if the username is L, user answer is L, guess number low val, the mid val, which is this number. So now mid val becomes the new low val, right? And we pass in the scanner again. So the low val is 10, and now the new mid val is 30, and he says it's still too low. So now we're coming back at the top. We got 10, we got 30. 10 and 30 divided by 2 is what? So 10 plus 30 is 40, divided by 2 is 20. So we're asking the question, is it 20?
It's not, hold on.
Do you remember your number, or did you forget it?
I still remember my number. The only problem is like if it's like
is it low, high, or yes?
like if the number is lower than my secret number, does that count as low or does it count as high?
So if it's still lower, then you'll say low.
It's still lower than my secret number.
Okay, so it's lower than your secret number. So if the user is low, right? Is it low? Yes. So the low val plus the new mid val is 20. Is that right? Still in the right? You're saying it's higher than the low val, than 20, right?
Yeah, yeah, my secret number is higher than.
Okay, so we're down here. So now the mid val, we're going to take 20 plus 1 and the high val. So now it's 21 and the high val is 30, I think, right? Yeah. Yeah. So this is 30 and this is 21. All right, this is getting confusing in my head. Y'all with me so far? All right. So now we got 21 and we got 30. We take 21, we add with 30, we add it together and we get what? 51 divided by 2. What is it? Well, we're just going to go to 25. So 25, is it 25?
My secret number is still higher than the.
Okay, so it's still higher. So now 25 is the mid val and the high val was what again? 30?
30. Yeah, it was 30.
All right. So 25 plus 1 is 26. This is 30. We come back up. So 25, let's see, 26 and 30. 26 plus 30 is, I hate math, 56 divided by 2. What is it? 28. Is your number 28?
Nope, my secret number is higher.
Your secret number is higher, so we're got to be getting close now because we've already.
It's okay. We start back from like the 10 and the 50 as the like the 10 is the low val and then the 50 is the high val. Can we start back there?
Can we start back there? Did we already mess up our math? Is that what you're telling me?
I kind of messed up the results.
Okay.
Because I did not know how like the results are gonna be like.
You weren't changing the number halfway, were you?
I still had the same number ever since.
All right. What was your number?
73.
Yeah, we're way off because it was a number between 10 and 50.
Oh, I was thinking of like.
This would never work. You lied to us, man.
I was thinking of 1 to 100. I was thinking of a number between 1 to 100. So.
All right. You guys get how this works, though, right? We're incrementally adding the numbers and coming up to the range. And this is still considered a binary search. All right. Anything that does not make sense here so far about this logic?
Is this in our books?
This is actually in your textbooks, yeah. Yeah. Okay, well, let's go on. So here is the full McCoy of this, right? We have the public static void main method at the bottom. We're saying choose a number between whatever and whatever. In our case, we set it to 10 and 50, right? And we did the higher and lower, and we came out with whatever. All right. There's a lot of different searches you could do here. There's also one called a tree search, and it's still using recursion. So with a tree search, you could take like a set of words. You could feed in a set of words and say, okay, I need to come up with all possible permutations of a 4-letter word. And it would give you every available letter permutation of that 4-letter word by just doing a shift, passing it in and printing it out. Okay? Different permutations. All right, so here's a problem that often happens when we're doing this type of recursion. When you're doing a very deep recursion, say if the recursion you're doing does not try to eliminate the set early on, you can end up with what's called a deep recursion. And deep recursion can lead to memory errors. Now, there's a famous website on the web that's named after this type of problem. Have you all visited this website? Everyone loves Stack Overflow, I can tell, because they give you all the answers on Stack Overflow. Here's the thing. Stack Overflow is a real issue. What happens is you have a stack in your memory. And in that stack, it's only set to hold so many operations at a time before it has to release the elements off the stack. When you're doing recursion, you can actually fill up the entire stack, and now it's overflowing. And when that happens, you'll watch your screen start scrolling, and it'll just say Stack Overflow, Stack Overflow, blah, 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 blah. It just keeps going on. And it's literally your Java runtime machine just puking, saying, I can't handle it anymore. You're messing with me too much. Like what he just did to us a minute ago with 73 is not between 10 and 50.
I didn't know what type of number you're asking for. I was just like thinking of
It's okay. I'm just messing with you, man. I'm just messing. Okay, so remember, memory is finite, so you can run into these problems in a Stack Overflow. Okay, any questions so far? All right, so this week is pretty light. We're going to do one more example, and this is going to be your lab. Okay, do you guys know do y'all know what a Fibonacci sequence is? You've never heard of Fibonacci? Oh, Fibonacci is awesome. All right, you guys Google Fibonacci real quick. If you got your computer out, go ahead and look up what a Fibonacci sequence is. It's often used in what's called the golden ratio, things like that. So if I have a number like, I take the previous number and I add it to the next number.
Okay, I can see how it works. It's very interesting.
Okay. So someone read off a Fibonacci sequence starting at 1.
0, 1, 1, 2, 3, 5, 8, 13, 21, 34, 55, 89, 144, 144, 233,
Yep.
377, 610, 987.
You don't have to keep going. That's good. All right, but you get the idea. This is what a Fibonacci sequence is. All right, in your lab assignment, you have to validate what the next sequence is for a number, Fibonacci-wise. Okay? So if I gave you a number, you'd have to say, okay, what that next number was with Fibonacci. So if the number is 7, what would the next number be? Using Fibonacci, it would be what? 13. Some of you are just like, I don't know what kind of math this is. All right, so again, you're taking the previous number and you're adding it to the current number. That's Fibonacci. So 7 plus 6 is 13. All right, so go ahead and let's go ahead and break out go ahead and open up Moodle first of all, okay? I want to highlight a few things this week before we jump into Fibonacci. Oh, that's weird. Okay. Let's see, do we have anything after this one? That's it. So, we're at week 11. We're doing recursion. Notice this week, PAs, CAs, and the lab. We're going to do the lab together here in a second. You have a discussion forum. There's also a video that goes deeper into recursion. If you guys are still lost with it, you can watch the video. Your discussion forum is asking you more or less about data abstraction, process abstraction, what classes are in objects, okay? Guys, these are easy grades. Just spend the time, answer the question, respond to someone else. These are really easy grades for you guys, okay? Your PAs this week, you've got 1, 2, 3, 4, 5, 6, 7, 8 PAs, okay? They're very basic. I have noticed when I was going through these today, I've seen where some of you may be doing this. So this is going to load, okay? And instead of clicking this link, I think some of you might be clicking that link. They're not the same.
Yeah, because you're still in the same window.
You're still in the same window if you click this link. It means that the grade won't pass through. Okay, so make sure you click the Moodle link. I know it's frustrating, okay, and I get it. It's frustrating to me that it doesn't connect it to the right spots, but just please make sure that you follow the Moodle links and not the Zybooks links, okay? All right, so you've got the 7 PAs, and we've got not a lot of CAs. They're very basic, okay? Very basic. And today, of course, we're going to do the Fibonacci sequence recursion lab. All right, so if you could, go ahead and open this, this assignment. And the requirement is, excuse me, Fibonacci's, is this turned on? It is now, okay. Fibonacci sequences begin with 0 and then 1 follows. All subsequent values are sums of the previous 2. Example 0, 1, 1, 2, 3, 5, 8, 13, okay? So you're going to complete the Fibonacci method, which takes an index, an n, and returns the nth value in the sequence. Any negative values should return 1. So if the input is 7, Fibonacci 7 is 13. Okay? So here is our code. Go ahead and select your code, copy that out. And let's open up IntelliJ. And we're going to create inside of our source a new Java class, and we'll call this lab. We'll paste in the basics of our code. Okay, I'm going to go back. Run your program as often as you like before submitting for grading. Below, type any needed input values in the first box, and then run the program to observe the output. Okay, so we're going to have to do some calculations here to obtain the Fibonacci. Let's take a look again at the requirements. The sequence is 0, 1, and then follows all subsequent values, okay, which takes an index, an n, and returns the nth value in the sequence. Any negative values should return negative 1. And notice what it says. Do not use any loops, because the task here is to learn how to do this with recursion. Okay? So let's open up IntelliJ. Let's think about what we have to do here. We're going to accept the n value, and the first thing we have to do is we have to see if the n is less than 0. So easy enough logic. How would we do that? If n what? Less than 0. Okay? If it's less than 0, what are we going to return? Look at the Moodle page. What is that we have to return if it's less than 0? Negative 1. Okay? Else, if else if n is less than or equal to 1, then we're going to return n. I made a mistake here in my code. Can't put spaces between the less than or equal sign. Okay. Now, that's the short circuit, right? So what we need to do is, if it doesn't meet any of these criteria, then we're going to do the methodology. So we're going to return Fibonacci n minus 1, and we want this to register against Fibonacci n minus 2. Now, some of you are going to look at this and go, huh, it's calling itself twice and adding the values together. It probably should make your mind melt a little bit here, okay? Because when you think about walking through the steps, what has to happen? It has to read from left to right, correct? So it's going to do this method first. It's going to take the n and then minus the 1. It's going to ask the question, and it's going to exit out if it meets the criteria. Otherwise, it's going to come down and call itself again ever before it gets to this second part to add to itself. It's like doing your taxes in real life. If you've ever had to do the scene of my taxes on your own, God help you. It's hard. I used to do these through TurboTax stateside, and I'd have to deal with drilling down into all of these subforms. And anyways, I'm off on a tangent. Okay. So here we have the basics of our logic right there. Okay. So we've got our scanner, and we've got our system out print line. Well, let's enter a number. Is it not declared lab program? Oh, I made a mistake. Name file. Y'all see the mistake I made? Okay. Instead of running this the typical way, let's go ahead and just set some breakpoints. Okay? Because we want to see what's happening when we run this. So we're going to right click on it, go to debug, and we're at get the next int. So I'm going to go over here back to run, and I'm going to put in 7. Whoops. What's going on? Oh, here we go. There we go. Now I'm going to input 7. Give me a second here. This is aggravating. Delete that. There we go. Let's debug it again. All right, so we're at this item. So we're at run. Where is the, there it is, 7. Okay, so now we're at this line, and the number we've input is 7, and it's going to pass into the Fibonacci. It's going to call the method now. So let me bring this over a little bit more. Okay. So now we're up here inside the method, and if 7 is greater than or greater than 0, return -1. Right? If it's, I'm sorry, if 7 is less than, return -1. If 7 is less than or equal to 1, return in. Okay? So we're down here, and we're going to say 7 minus 1, right? And we know it's going to be 6. And then here it is 7 minus 2. So we're going to pass this in again. We're at 6. It's going to skip over, and now it's n minus 1. And we're just going down the rabbit trail till we finally get to 0. Now we're into the second one, which should be what? N is 0. So returning in. Okay, good. Now we're over here. And now this is 1. It's going to keep going down, drilling down upon itself, passing these numbers, right? So this could go on for quite a while. So let's go ahead and let's see. Okay. You see over here, it just keeps calling itself, right? You can see the factor is going up. You see the factor over here on the side? It's going to eventually reach 13, and then it's going to quit. There you go. All right, so let's, without debugging, let's just run it without debugging, and let's just enter, is it still in debug mode? It is. All right, so we'll run it normal. We're going to put in, let's say, 13. There's then the Fibonacci of 13. How many's mind is still with me so far? A little bit? The mathematics is a little complicated because of what a Fibonacci sequence is, but if you look it up, Fibonacci sequences have been found to be used, helpful in creating these large table of Fibonacci sequences. Those sequences are helpful in statistics, with AI, with a number of other, even in art, they're starting to use it in art now. Okay, that's the lab. So let's copy our lab and go back in. Let's paste this in. Let's go back to develop mode and just input a number here, 7. Run the program, 13. Okay. Let's try something else. Let's try 6. It's 8. How about 67? That should be a very large number. We might crash the server with that number. I might have been better. Yeah. There you go. Remember what I said about Stack Overflow? So if you try this on your own computer, let's see here. What is 67? Let's see if it crashes your computer. I've got a pretty robust system, but I bet this is still going to screech it to a halt. What do you all think?
I tried 50, it didn't work.
50 didn't work? Let's see. You can see what it's doing right now. It's using up 99% of my processing. You see the command, right? All right, so Fibonacci sequences can be pretty large, but this is also a good reason. I'm actually teaching a class right now on LinkedIn Learning, and we're looking at reasons why you might want to cache certain sequences. And Fibonacci sequences are one of the things that you would probably want to cache once you've calculated them. You understand what I mean by caching? So caching just means that you're sticking it into a file so that the CPU is not going off crazy like this, right? All right, so I'm going to kill that because I don't think we're going to get out of it. Okay, so if we go back to over here, that's develop mode. Let's go to submit mode. Submit it for grading. And we passed all 10 tests. Okay. Did everyone pass your test for the lab? Okay. All right. That pretty much covers what we're doing here in a nutshell. We've got about 25 minutes left for class. At this point, if any of y'all need help with your Project 3, I'll be available for the next 15 to 20 minutes. Otherwise, don't forget this week you have your quiz that's due, as well as midterm exam 3. Midterm exam, I'm sorry, part 2 of your midterm. Okay? Let me turn this off.